Today we are going to work on attributes of cubic functions, and this will be a guided practice, so it'll give you a chance to practice some of the things you've learned, such as degree, name, is the function odd or even, what's the leading coefficient, and what's the end behavior. This is TEKS from Algebra 2A. So we've been talking about polynomials for a while, and so we're going to deal just with cubics in this video. So cubics means that all of my equations are going to have an x cubed. Okay, so some of the important things we're going to have to look for here is, since we're dealing with x cubed, our degree is going to be a 3, so we're dealing with cubics. And a sub n is just what's your coefficient in the front. What is the number in front of your x cubed? Another important term is a sub o is just it stands for your constant. So this is just a number that doesn't have a variable attached to it. So here is practice number 1 done for you. Let me explain what we're doing here. First of all, we're going to be dealing with the third degree. This is an odd number, which is going to be important for end behavior. Third degree is always a cubic. And the leading coefficient is the number in front of x cubed. In this case, if you don't see a number, your leading coefficient is 1, since every variable has a 1 if you don't see the number. So now I want you to pause this video here and do the same thing with example number 1. Okay, go ahead and check your work. So again, third degree, which is an odd number, and if you have a third degree, it's a cubic function. And the leading coefficient is the number in front of x cubed, so it should have been a 5. And it's a positive 5, which is going to help us on the next page. So practice number 2. So again, we are dealing with a third exponent. We make sure that they are in order, and this is in order, so this is in standard form. This is a third degree, which is odd. Remember that if you ever have a third degree as your highest degree, it's cubic. And the number in front of x cubed is going to be my leading coefficient. In this case, it's a 1, and it is a positive number. Okay? So now we're going to go ahead and we're just going to the next page. So let's talk about the most important thing today. Is that going to be that end behavior. So if your degree is odd, which is what cubics are, then we're going to have to look at the leading coefficient and decide if it's positive or negative. If it's positive, so if it's a third degree or a fifth or a seventh, if the degree is odd and the leading coefficient is positive, every single time, this is how your graph, your end behavior is going to look. So this dash line doesn't mean anything. All I care about are looking at the arrows at the end. So I have that arrow, which my end behavior there is going to be this. My function, f of x, is approaching negative infinity because it's going down forever as x is approaching negative infinity. So on the left side of my graph, this is always x approaching negative infinity, and the other side is always x approaching positive infinity. So on my right-hand side, where is that arrow going? Well, as my function. So my function right here, my f of x is approaching positive infinity because it's going up forever, as x is also approaching positive infinity. So the x values are not going to change. On the left side, it's always negative infinity. On the right side, it's always positive infinity. Now, if my leading coefficient is a negative number, it's going to be basically a mirror image of this. It's going to reflect over this axis. So on this left side, my function is approaching a positive infinity because it's going up forever, as my x value is also approaching negative infinity. On my right side, my function of x is approaching negative infinity as my x is approaching positive infinity. So here are some examples of what an equation would look like. I see a positive 2x cubed. In this case, I see the negative 2x cubed. So here are 2 more examples. Guys, these graphs are not at the parent function. All we care about is that it had an odd. We can say that this had an odd degree and the leading coefficient was positive, and it ends going positive. So on my left side, my function of x was approaching the negative infinity because it was going down forever. And on my right side, my function of x was approaching positive infinity. And if you look at this graph, this is the complete opposite. Now, this graph is not a mirror image, okay? This graph might have a stretch, it might have a compression, it can go left and right. None of that changes your end behavior. On the left, it's approaching positive infinity, and on the right, it's approaching negative infinity. So now let's go ahead and practice some of that, okay? So here is example number 1, and here is my equation. The only thing I need for this is I need to know what my degree is. My degree is 3, and so it's odd, okay? And my leading coefficient is -4, so as we said, it's negative. So I'm going to follow one of these. So this tells me it's going to end negative, so that lets me know this one is my graph. The degree was odd, and my leading coefficient is negative. So this is what the graph is going to look like. Does it matter where I put the graph? No. That's why the axes are not labeled. But I know what my end behaviors are going to look like. So my left end behavior is what I'm going to write first. My function of x, my f of x, is approaching, where is it going? It's going to positive infinity first. And x on the left is always, 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 x is approaching negative infinity. On the right-hand side, what's happening to this end behavior? What's happening to my graph? Well, the graph is approaching negative infinity. On what side? It's approaching negative infinity as x is on the right side, which is positive infinity. So go ahead and pause this video and try practice number 2 on your own. Okay, so actually, guys, guess what we gave you guys? We gave you guys the exact same type of graph, the same end behavior, because my degree was 3 and my leading coefficient was a negative number. So we did not flip them on you. So on the left side, it was going to positive infinity, and on the right side, it was going to negative infinity. Okay, so now this one did not give us the graph. This one gave us the end behavior, so let's look at it. My function, my graph, is approaching positive infinity. Where is it approaching positive infinity? When x is negative infinity. So where is my x negative infinity? It's negative infinity on this side. So when my x is approaching negative infinity, this graph is going up on this side. Now, when my x is approaching positive infinity, so when my x is approaching positive infinity, my graph is going down forever. So it doesn't matter what's happening to the graph here. It can curve multiple times. Okay, it does not matter. What matters is that end behavior. So that's where the ends are going to go. So let's read that second one. Go ahead and see if you can rough sketch this graph. What do you think is going to happen with this graph? Well, let's look at it. So always, 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 this is always negative infinity, and this is always positive infinity. So that's your x value. So as x is approaching negative infinity, so on this side of my graph, my left side, my function, my f of x, my graph is going to negative infinity. So on this side, my graph is going to negative infinity. Okay, now as x is approaching positive infinity, what's happening to my graph? My function of x is approaching positive infinity. So on the right side, my graph is going up forever. Again, depending what power you have, anything can happen with this graph. Sometimes they have very noticeable curves, sometimes they don't, but what we know is that the end behavior, okay, will always look like this. Hopefully this video exposed you to what end behavior looks like for cubics and gave you an idea of some of the attributes.